All right, base your answers to questions 21 through 25 on the information below and on your knowledge of Earth and space sciences. Some questions may require the use of the 2024 edition reference tables for Earth and space sciences. We're starting a new cluster for question 21, and it's going to go through question 25. So just a reminder that when you have a cluster, all of the materials are fair game for every question that is included in that set. So this reading could pertain to question 22, 24, 25, doesn't have to be on the same page or come before it. So any resource could be used for any question that's given. So it says New York State's Hudson River. New York State's Hudson River watershed covers almost 1,340 square miles and includes 3 different watersheds: Mohawk River, Hudson River Estuary, and Upper Hudson River watersheds. The Hudson River flows south for almost 325 miles from the Adirondacks to New York City. The 153-mile section from Troy to New York Harbor in New York City is a tidal estuary. Here, fresh water flowing south down the river meets salt water pushing in from the Atlantic Ocean. The leading edge of sea water entering the estuary is called the salt front. The salt front moves with the tides, the weather, and the seasons. When there is heavy rain, more fresh water flows into the Hudson River. Cities and towns that take their drinking water from the Hudson River carefully track the salt front as it affects the quality of drinking water. And then we have a model. So I'm going to look at this model. I'm going to think about what they told me. So they told me that the Hudson River flows south from the Adirondacks to New York City. So I'm going to look, and there's my Adirondacks, and New York City, or New York, is down here. So I'm going to just kind of draw an arrow to remind myself that the Hudson River is flowing this way, in this direction. Okay, they told me what the salt front was. So they said that the salt front is where the seawater enters the estuary, which is where kind of like your seawater and your fresh water are meeting each other, and that's your salt front. Okay, and they told us that we monitor it because it affects the quality. So remember, we want fresh, clean drinking water. That's a human societal need, and so we want to make sure that that water we're able to get access to is fresh and clean and able to be used. Okay, our question says, describe how heavy rain events along the Hudson River would affect the location of the salt front. Okay, so I have to think about what would be happening if I had heavy rain. So we know that if we have heavy rain, it's going to run into that river, and they told us the river flows south. So as the rain occurs, more rain is going to cause more discharge, so more water in the river. It might make it speed up and move a little bit faster, and so that is going to cause a greater flow towards the south. And if we have our salt front, so let's say our salt front is, I'm going to mark it in blue. So say our salt front is right here, where the ocean is pushing upward. If I have more water flowing through the river, that's going to push that salt front. It's going to have more force behind it. It's going to push that salt front this way. Okay, so we could write, we had to talk about what was happening to the salt front. So if we read this question carefully, it says, describe how it would affect the location of the salt front. So we had to make sure we talked something about location. So we could talk about the direction it would move. We could say it would move compass direction. We could say what city it might move towards. Okay, and so for this question, I would write something like the salt front would move to the south, right? So we could say salt front. Sorry, I'm using a different app today, which is making them a little bit harder. It moves to the south. Okay, so the salt front moves to the south. We could have said something like it would move closer to the ocean. So it's going to be pushing that salt downward away from the fresh water that's flowing through the river. Okay, and they gave us another little background information here. So it says the location of the salt front is measured in HRM, Hudson River Mile units. Hudson River Mile 0 is at the southern tip of Manhattan in New York City. The tables below show some information about the salinity along the Hudson River for several locations north of New York City on 2 different dates. Salinity is measured in milligrams of chloride per liter of water, milligrams per liter, and the salt front is located where salinity is 100 grams per milliliter. So they're giving us information about how they find where the salt front is located. Okay, so I have two different data tables. The first thing I'm going to look for is what is different about them. So as I look at this, I see that they both have location. The locations are the same: New York City, Yonkers, Piermont, Bear Mountain, Cold Spring, Ulster. So this one does have Poughkeepsie, which this one does not. Um, and my salinity is there, salinity, HRM, that's there. And I see up here my titles, October 6th and October 12th. So they've given me two different dates, essentially. So data that was collected from two different times. So our question says, a student makes a claim that the location of the salt front is constantly changing. So this is our claim here, due to the weather conditions. Which table below supports the student's claim by correctly identifying the two locations between which the salt front was located on October 6th and October 12th? Okay, so we want to know where the salt front was located on the two different dates. Now, I want to think about what this claim means. So the claim says that the salt front is constantly changing. That means I should find it in different locations if that is true. And so we're going to check each date and see where that salt front was located. Okay, so we know that the salt front is where salinity is 100 milligrams per liter. They told us that in the reading. And so we're going to look at where that would fall in our data table. So on October 6th, we want to look and say, okay, 100 milligrams per liter. So I see those units right here. I see 100 milligrams per liter, or milligrams per liter, and that's the units we used in this number. So I'm going to look in that row for both of these. Okay, so if I look at these numbers for salinity, I need to figure out between what two values would 100 fall. Okay, so I'm going to show you that way on the first one, and then I'm going to show you another way that you could have done this if you maybe struggle with finding where that number would be. So if I look, I see that these are arranged from smallest over here to largest over here. So if I assume this was a number line, 0 on this end, 34, 47, 50, 300, 100 would fall somewhere between 350. So this blue line is my salt front, okay, because 100 would be between 350. So on October 6th, we had the salt front between Piermont and Bear Mountain. Okay, so I'm going to look. There's Piermont, Bear Mountain. That works, that works. This one does not work. This one does not work, so I can eliminate option 3 and 4. Okay, then I'm going to look at October 12th. So I have two possible locations. So what you could do if you weren't sure in terms of how I just did it on the first table, you could look at it and say, okay, my first option says it's between Poughkeepsie and Ulster. So Poughkeepsie has a value of 30. Ulster has a value of 64. 100 is where the salt front is located. So if I go between Ulster and Poughkeepsie, 64 and 30, would there be 100? And the answer to that one is no. So this does not fit. So 100 would not be located in between those two locations. So I'm going to X that out. And I'm going to go on to my next one just to check it, to make sure I didn't make an error. Verplank is at 830. Cold Spring is 50. So if I was to count from 50 to 830, I would hit 100. So our salt front is between those two locations, and that means our answer is number 2. All right, my next question says, an advancing salt front along the Hudson River can affect the quality of drinking water for communities such as Poughkeepsie, which use fresh water from the river as a source of drinking water. For this reason, two different environmental groups carefully monitor the salt front in the river. Since over 10 million people in New York State rely on the Hudson River for clean drinking water, both environmental groups have developed a plan to evaluate salt front advancement and to prevent the salt from entering the drinking water intakes. Okay, so far they've told us in the first paragraph that we monitor the salt front because we need to use it for a source of drinking water. Our second paragraph talks about the idea that we have some groups who are developing a plan. And the plan has two pieces. So it says the plan is to evaluate salt front advancement and then to prevent the salt front from entering the drinking water. So we're kind of talking about like observational data. So what's happening right now is our evaluate. And then our prevent would be like kind of making predictions or kind of helping to prevent changes in the future. This $400,000 plan has a budget to monitor and evaluate salt front advancement over the next 35 years. This budget has two components summarized below. So our total is $4,000. I'm just going to label that's our total. And they're telling us here how it has been allocated or split up, okay? So they allocated $250,000 to predict salt front location. So this is to make observations, collect data, $250,000. So that's kind of for the current, like what's happening right now. Then they've allocated $150,000 to develop a proactive plan. So this is the now, and this is the future. Okay, so I'm going to give more money right now to kind of just collect data, and then I'm going to give money set aside for preventing or kind of come up with a plan of how can I keep this from happening more, or what can we do if this was to advance? How could I treat it? So it says, based on the evidence in the plan developed by the environmental groups, which explanation correctly describes how the availability of fresh water will influence communities along the Hudson River? Okay, so my first one says, cities along the Hudson River will need to spend considerable amounts of money to find alternative drinking water sources as the salinity decreases over the next 50 years. Okay, so I would think that this stands out here. So salinity decreases. If salinity was decreasing, then that would be kind of on the positive side in terms of we want water that does not have a high salinity, right, to drink. So I don't think that at this time that stands out as the best answer, but I'm gonna leave that there, and then I'm gonna keep going to see if I can find a better answer that's given. So 2 says cities along the Hudson River will need to spend $400,000 to monitor the salt front over the next 50 years. So we have $400,000 to monitor, okay? But if I go back up here, it said that my $400,000 was to monitor and evaluate salt front advancement. Okay, so that answer is missing a piece because it does not just monitor, it also evaluates, and it also develops a future plan. So there was 2 pieces there, and this is only mentioning 1 piece. So 2 is not a good choice. 3 says communities that use the Hudson River for drinking water will spend $400,000 to monitor salinity and develop plans to purify water if necessary at water treatment plants. So they have our total, right? They have the monitor, and they have the develop. Okay, so right now we have our total. I'm marking with a T. We have our now, and we have our future. Okay, so that's looking like a pretty good answer to me right now. I think that looks like my best option, but I'm going to read 4 just to make sure. 4 says communities that use the Hudson River for drinking water will need to spend $150,000 to predict whether the salt front will affect their drinking water. Okay, so it says communities will allocate $150,000 to develop a proactive future action plan. But when we look for predict the now, that was not $150,000, that was $250,000. Okay, so that our number value makes that incorrect, right? So our $150,000 was to develop an action plan, not to predict salt front locations. Okay, so 4 was not correct. So I was left with 1 and 3. And 3 is the best answer that I can come up with that is supported by what was up here, right? So it said based on evidence. So number 1, that could be true, right? I might be spending a lot of money to find alternative drinking water sources until the water becomes completely clean. But at this time, I don't have any evidence of that based on what they have given me. So that would not be my best choice. I think number 3 would be my best choice there. All right, we have another reading introduced for 24 and 25. So it says the location of the salt front and its effect on drinking water quality is not the only issue facing residents along the Hudson River. Between 1947 and 1977, industries that manufactured substances used in fire prevention and oil insulators called PCBs were found to be toxic to humans and life in the river. By then, the industry located north of Albany had dumped an estimated 1.3 million pounds of PCBs into the river. Once in the river, the chemicals mixed with sediments in the river bottom and along the shorelines. The removal of a dam in the upper Hudson in 1973 further released large amounts of contaminated sediments. So right now we're talking about industries have dumped toxic substances into our river. It's been absorbed into the sediment. And that's what they're talking about here. They're just giving us some information about how it happened. This is in 1984, the Environmental Protection Agency classified a 200-mile stretch of the river as a federal Superfund site that required the removal of the PCBs from the river sediment. A 40-mile stretch north of Albany was termed as a hotspot where PCB contaminated sediment was removed by dredging between 2009 and 2015. The model below shows some information on PCBs in the Hudson River. So here's our Hudson River Superfund site, and they've showed us kind of what's happened. So here we have our contaminated sediment at the bottom, this darker color. Here's our salt front they were talking about. So we have our ocean water meeting our fresh water. We have a couple dams that are in place, so they're holding back the sediment in a couple of these areas, and they're showing us our industries and our different locations, right? Our different cities. Okay. It says eating contaminated fish is the single greatest human exposure to PCBs. The PCBs in the upper Hudson River have been present for 70 years and have accumulated in fish. The EPA issued an advisory to not eat fish taken from the upper Hudson River. In 2002, the EPA adopted targets of PCB concentrations in fish to be reached by 2020 and 2031. The graph below shows PCB concentrations of fish taken from the upper Hudson River and these targets. Okay, so they're talking about how fish being in this water that was contaminated have kind of absorbed some of that contamination, and so we should not eat those fish. And they have taken some steps to kind of monitor and see how those levels are changing in fish over time. So it says weighted average total in upper Hudson fish 2016 to 2021 compared to EPA's target. So they have two things on here. So they're showing us the weighted average and the targets that were set. Okay, so in a graph, especially when I see multiple things going on, I'm going to kind of look at my key here. So they've told me that these black boxes are the weighted average in the fish. And so that's going to be these here. And then they've told me that these lines are going to represent my EPA target. So my lighter gray was my EPA target after 5 years, and my darker gray was my EPA target for 16 years. Okay, so dredging is where they kind of take this machine and they remove some of the sediment from the bottom of the body of water, and they're removing some of those contaminants. So they're hoping that by removing these contaminants, the levels of PCBs in the fish is decreasing, and their goal is to reach these green and yellow lines here. So it says, based on the model and graph, which would be the next logical solution that would cause the greatest decrease in PCB levels in fish in the Hudson River? So we're looking for which one would cause the greatest decrease. So not just a decrease, but the greatest decrease. So one says, do nothing and let the river naturally remove the PCBs into the Atlantic Ocean. Okay, so probably doing nothing is not going to get us the greatest decrease. So I'm going to say number one is probably not my best choice. Number two says dredge additional areas that still have PCBs and sediment to permanently remove pollutants from the river. So we're permanently removing those pollutants. So I think that looks pretty good right now. 3 says build another large dam where the dam was removed to capture most PCBs before the contaminated sediment moves downstream. So you are going to remove or capture, you're going to capture the PCBs. So you're not really getting rid of them. So even though you are holding them back from where the fish are downstream, it's not really removing it from the water. So again, I don't think this is the best solution. Let's read number 4, breed larger fish that can remove PCBs from the water and sediments. Again, a very timely solution, right? And we can see from our data here that while our measurements haven't reached target, they are decreasing as we have dredged. Okay, so I'm going to say that number 2 is my best option in terms of something that I can do quickly and something that is going to have a great effect on our population of fish. Okay, 25 says explain how the graph supports the claim. So we're using the graph, and we want to show how it supports the claim that dredging of the Hudson River has only been partially effective at reducing PCB levels in fish compared to EPA targets, okay? So they want us to talk about both EPA targets and PCB levels in fish, and they want us to use the graph to talk about kind of why it hasn't been completely effective, okay? So if I look here, completely effective would mean that those levels of PCBs in the fish have reached target, these green levels and these yellow lines, but we see that that is not the case, okay? So while our fish have shown a decrease in the change in the amount of PCBs, they have not quite reached their target yet, okay? So there's partial effectiveness, right? It's partially effective in the fact that it's lowered those numbers, but it's not completely effective in the fact that it has not reached target. Okay, so I might write for this one something like PCB levels have not reached EPA targets. Okay, so I'm using information from the graph, and I'm talking about both EPA targets and PCB levels, and I'm talking about why they're not completely effective. Okay, so that would be my answer for 25. So that is our next cluster. You can see that they're all linked around that same idea of contamination of water sources, and they all are focusing on that concept.